Okay, here in number 2, I'm writing, this is red, all this math symbology is shorthand for English words. The gradient of the natural log of x squared plus y squared, evaluated at 1, 1, is equal to, let's see, the vector, whose components are d dx and d dy, the operators, acting on the natural log of x squared plus y squared, and then evaluate at 1, 1. Okay, that means you put in the first slot the partial derivative with respect to x of natural log of x squared plus y squared. Using the chain rule, that's 1 over x squared plus y squared times the derivative with respect to x of x squared plus y squared. That's just 2x. And similarly, the derivative with respect to y is put there. And then we still have the instruction to evaluate at 1, 1. So 2 times 1 over 1 plus 1, that's just the vector 1, 1. All right. So we have found the gradient of that function at 1, 1, the point 1, 1, and it is the vector 1, 1. We're meant to draw this, so I will say is drawn below along with the level set of the function that we're talking about, natural log of x squared plus y squared, corresponding to, well, what value? See, we're meant to be looking at the point 1, 1. So the level set that we're interested in is the level set that passes through the point 1, 1. And that is the set of all points in R2 such that the natural log of x squared plus y squared is equal to the same thing. What thing? The value of natural log of x squared plus y squared at 2. That is natural log of 2. So here that's natural log of 2 in case you can't. Let me do it with the small pen. Natural log of 2. There it is. No, the idea is natural log of 1 plus 1. Right? So that is the value of natural log of x squared plus y squared at the point 1, 1. There's lots of other points on the plane where natural log of x squared plus y squared is the same thing. In particular, this is the solution set to the algebraic equation x squared plus y squared is equal to 2. Okay, and that means we have a circle here of radius square root of 2. Centered at the origin. And let me go ahead and say that this is the x-axis and this is the y-axis. And negative square root of 2 is going to be over here. And up there, we'll have a square root of 2 and then negative square root of 2 down here somewhere. Okay. Here is that level set. And on that level set is the point 1, 1. And that point 1, 1, think about it, natural log of 1 squared plus 1 squared really is the natural log of 2, so that has to be on the circle. And we are meant to draw the gradient vector 1, 1. That should point just as much to the left, or sorry, just as much to the right as it points up. It's about like that. And as usual, that is orthogonal to, or normal to, the level set. Let me draw here a green line that is tangent to the level set and say that we have a 90-degree angle between the red vector, 1, 1, and the tangent vector to the circle at this point, the point being, all right, 1, 1. Okay, so this time we see that the gradient is not a constant function. No, it changes with x and y, and you can imagine what would happen if we evaluated the gradient at other places. The direction of the gradient would change. So here, I'll get my red pen, just be properly color-coded. If we looked at the gradient over here at this point, it would point in that direction, normal to the level set. And if we looked over here, I'm thinking of this point right here at the end of my red pen, gradient vector would point that direction. Okay. So the gradients always point normal to the level sets.